Hello, I am Kati and today I'll be talking about the analysis of Chuan Xiong herb. I believe most of you are unsure of what Chuan Xiong is, so right now I'll be sharing a little about this herb with you all. Firstly, Chuan Xiong can be called Sichuan lovage or Linguisticum stratium too. It is native to India, Kashmir and Nepal, but nowadays it's mostly grown in China, Sichuan. Secondly, about Chuan Xiong's properties. It is usually known as a flavorful herb. With a strong fragrance, spicy and bitter taste, it is also warm in nature, which is commonly known as a heaty food in traditional medicine term. Its appearance is very similar to ginger too, with the big and firm form of yellow and white cross-section. That is how a Chuan Xiong will look when it is being sliced. In addition, Chuan Xiong is taken directly in small amount in forms of powder form, together with water or tincture form, which is made by dissolving in alcohol. Chuan Xiong is also taken more frequently during the autumn season, and it is also known traditionally to be a cooler and drier season than summer. There are two main types of Chuan Xiong, one being just the natural and unprocessed Chuan Xiong, and the other is Jiu Chuan Xiong, also known as Chuan Xiong being fried in wine. Now, I will talk about the challenges commonly faced in chemical profiling. Number 1 is about the overlapping compounds in the total ion chromatogram, also known as TIC. As the compounds that elute at similar retention timing, they will usually overlap each other. Number 2, the trace compounds. Together with number 3, unknown compounds are normally overshadowed by the other major compounds or background noises, thus making them hard to be found and detected. Moreover, challenges faced in data analysis are relatively similar to chemical profiling too. Firstly, co-eluting compounds with similar retention timing are hard to be separated. Secondly, the high background noise will definitely affect the detection of trace compounds. Lastly, the technology limitation will result in the unknown compounds to stay unknown till more research are carried out. Thus, this will in turn lead to more complications in researchers and the work of analysis. Thankfully, the limitations of chemical profiling and data analysis can be lowered with the technology of ChemoPower technology. With the Smart Dalton and Molecule DB software, experimental data can be analyzed through mathematical models so as to provide a clearer and more accurate result. Starting off with Smart Dalton. It is a software that incorporates the spectral deconvolution technology for the separation of co-eluted compounds. Plus, there is a 3D surface plot function to allow users to better visualize and assign the background easily for better identification of compound. So this is the Smart Dalton software. The top graph represents the TIC area, and at the bottom left is the 3D surface plot of the graph. While this is the deconvoluted graph that allows background assigning or a more precise analysis of compounds. Next up is Molecule DB. It is a software related to Smart Dalton, as Molecule DB is a database builder that reads data from Smart Dalton and assigns them into a specific component afterwards. Molecule DB is able to provide mass spectrometry library match service and head-to-tail analysis of the sample to the library data, so as to offer greater accuracy and convenience in chemical analysis. Thus, this is the head-to-tail analysis available. Besides, match value and chemical formula of compounds are shown here for a more convenient analysis as well. Hence, after the comparisons between verified compounds of 3 Jiu Chuan Xiong samples and 3 Chuan Xiong samples obtained from different sources, Chuan Xiong samples are found to consist of more verified compounds than Jiu Chuan Xiong samples. In total, an average of 116 verified compounds are detected. These are the results of the categories of verified compounds of all Chuan Xiong samples. Later on, I compared the verified terpene results and observed no trend in the number of terpenes corresponding to the type of Chuan Xiong samples. As a result, I carried out with the principal component analysis, also known as PCA, to find out more about the relation between Jiu Chuan Xiong and Chuan Xiong. SPCA is a method used to analyze large sets of data. A clearer and more precise understanding of the relationship between samples can be obtained. Thus, according to the analysis of score, the two Chuan Xiong samples and Chuan Xiong samples can be seen clearly separated as they are clustered together at opposite ends. According to the analysis of the loadings, there are also some unique and special compounds related to the individual type of Chuan Xiong. Like as seen in this graph, these compounds on the left are highly correlated to Chuan Xiong, while the others on the right are highly correlated to Chuan Xiong. Evaluating the complete linkage clustering analysis, I can also deduce that the Chuan Xiong samples of different sources are more correlated as compared to the Chuan Xiong samples too, as the Chuan Xiong samples are more closely linked than the Chuan Xiong samples. Therefore, through the analysis, these components are detected and found to be unique to the individual Chuan Xiong types. So, some significant compounds of Chuan Xiong are alpha-2-gene and beta-2-gene. They are both under the monoterpene class and they contribute to the pungency flavor of the herb. Next, the D-alpha-pinene is a bicyclic monoterpenoid that is commonly found in oil, such as the eucalyptus oil. And the alpha-terpenine is a monoterpene that can be used as a flavoring agent that produces a terpentine-like odor. Following, the significant compounds of Chuan Xiong are beta-selenin, which is under the class of secresterpene that produces a herbal odor. Well, alpha-pinene and gamma-terpenine is similar to the ones in the compounds of Chuan Xiong. There is also sabinin, which is a compound that gives off a spicy flavor. Lastly, terpinolene is a monoterpene that is responsible for giving off a woody and piney smell. Therefore, all the significant and unique terpenes identified are all essential for giving Chuan Xiong its particular aroma. As a result, these volatile terpene compounds can also be further studied to find out more about their individual effect other than its sense description. With that, I'd like to end my presentation and I hope you have a better understanding of the aroma of Chuan Xiong. Thank you.